Hey, welcome back. Good to see you again. Today we're going to continue on electricity and we're going to study on the ammeter and the voltmeter, all right? So I have me over here, all right? So these are the 2 meters that you can find in the laboratory, okay? In commercial use, they don't really look so big and chunky. So the ammeter, you can see that there is a symbol A over here, and the voltmeter, you have a symbol V, all right? Okay. So in an electric circuit diagram, all right, both meters are represented with a circle and an alphabet inside. So for the ammeter, what is inside is the alphabet A, okay? So this is a ammeter, all right? Okay? And since ammeter, ampere, what does it measure? It measures current, okay? All right, so an ammeter measures current. And how must it be connected in a circuit? It has to be connected in series. All right, later I'll explain a little bit more. Okay. Next, you have your voltmeter. Voltmeter inside the circle, we write a V. So if the ammeter, ampere, measures current, what does the voltmeter, volt, measure? Yes, you are right. It measures potential difference. Okay, and the voltmeter have an interesting characteristic. It has very high resistance. Okay, whereas the ammeter has very low resistance. Okay, so voltmeter, because of its high resistance, it need to be connected in parallel. Okay, which I will describe later. So let me frame this up. These are the key things you need to know. Okay, let's illustrate this. So I have one circuit over here. Let's call this R1, resistor R1, R2. Okay, so I have 3 circles here. So let's say this is ammeter 1, ammeter 2, and ammeter 3. Okay, all right. If I mark out the conventional current flow, so I say this is I1, then I1 comes here, come to a node. When the current comes to a junction, it will divide itself. So this is I2, and this is I3, okay? All right? The quantity of the current is dependent on the resistance on the pathway. We'll cover that later on, okay? Right, then they join back, then it comes back here. All right, so I1 comes here, you will split into I2 and I3, they come back together, and you will, so this is also I1, all right? So this is also I2, this is also I3, okay? So ammeter A1, what does it measure? It measures the value of I1, okay? Ammeter A2 measures I2, okay? Ammeter A3 measures I3, okay? So you see the ammeter is connected right on the pathway where the current flows through. That's what we mean by connected in series, okay? Why is it able to do so? Because it has very low resistance, okay? What is it supposed to measure? How fast the charge is moving, all right, per unit time. So let's say if you want to see how many people is like walking through a door, okay? Do you like stand in the middle of the door and like a goalkeeper, right? Then that won't be accurate because you are blocking them. So you want to be at the side and then you let them through, okay? Then you can measure the true speed. And that's what the ammeter does. It has very low resistance, so it can be connected on the pathway itself to let it go through, okay? You can also see it like, maybe like a pedal, as when the water goes through, the pedal start to turn. So if the pedal is like very hard, it will slow the water down. So that's why you need to put oil, all right? It spins very fast, okay? So that's the ammeter. All right, second example. So I have another connection over here. So here I have resistance R1, resistor R2, and then we have R3, okay? And let's label the points. So let's say this is point A, B, this is C, D, okay? All right, voltmeter. If I want to measure the potential difference across, okay, the EMF, I will connect the voltmeter like this. So this is V1, all right? I want to measure the potential difference across AB, I will connect it like this. B2. All right, and this is V3. All right. So do you see that it is all connected in parallel? It is overwatching. All right. It is not along the pathway. Why? The voltmeter have very high resistance. If you put it over here, the current won't be able to flow through at all. Nothing is going to happen. Okay. So V1, what does it measure? It measures the EMF. Okay. All right. Because it's right across the cell. V2, what does it measure? It measures the potential difference across points A, B. All right. It also measures the potential difference across R1 and the potential difference across R2. We will cover that concept in the following videos. V3 measures the PD across CD, all right, across these 2 points, which is also the PD across R3. So I can also say PD across R3, okay, all right. So this is how we connect in parallel, all right. Okay, let me draw another line. Okay, so again, characteristics of voltmeter, very high resistance. You need to measure it. You need to connect it in parallel. All right. Okay. Last question. Okay, and we are done. So let's say if this is a 2-volt battery, and let's give this like a 2 ohm resistor, and I have an ammeter here, and I have a voltmeter here. The question is, what will be the reading on the ammeter by using this setup? Yes, the answer is 0. How do I know? Because the voltmeter have very high resistance. No current is going to flow through. So if no current is going to flow through, ammeter is going to detect 0 current because voltmeter is connected wrongly. All right? Okay? All right, the high resistance will prevent the current to flow. So ammeter reading will be 0. Voltmeter reading will also be 0. All right? So I hope you get this concept, ammeter, voltmeter. See you in the next video.